Hello, welcome back. Today, we'll talk about the average rate of change. So, what I do is, as our goal state, to find the average rate of change between 2 points and also interpret what it means. So, let's look over here on the left. So, the average rate of change, and we'll look at the average rate of change between 2 points, just like x1, y1, and x2, y2, is given by this. If this looks familiar, it should. If you see my video on, if you know about the slope of a line, this is exactly the same formula. It's the change in y over the change in x. And once again, of course, x2 can't be the same as x1, or else it'd be undefined. It's exactly the same as the slope formula. So what that means, what it tells us then is it's the same as the slope. It gives you the same information, the same value as the slope of a line between 2 points. And also it's the same property. So if it's positive, means its average range is increasing. If it's negative, means it's decreasing. Of course, if it's constant, if it's flat, it means it's constant. And also, you could also think about parallel lines and perpendicular lines in the same way, although we don't usually think about that as much with average rate of change, but it's exactly the same properties as the slope. Okay. Now, what it doesn't do, it does not take into account what happens between these 2 points. And we'll look at an example here in a moment to explain this better. And also, if you change one or both points, the average rate of change will likely change. So it's not some kind of a property of the graph you're looking at in general. So let's come over here and let's draw some sort of a graph. So maybe you have a graph that looks like this. Maybe you're imagining, maybe this is think about a mountain. So maybe you're climbing a mountain or a set of mountains. And let's say you want to take between, let's say this point right here. Let's say this is our, we're going to call this our x1, y1, though it doesn't matter. And let's call this our x2, y2. Okay. So we think about the line that connects both of those points. Then the slope of that line is the average rate of change. Okay, so remember m, so we call the slope, or m is equal to the slope of that line is the same as the average rate of change. And once again, it only tells us what happens between these 2 points. It doesn't take into account anything goes on between. Okay, so it tells you. So if you notice, if you're thinking about this as a mountain, if you're walking up, you have to walk down and walk back up this point. Doesn't take any of that account. It's just imagine if you went at a constant, walked at a constant rate of increasing elevation from here to there. That's what that average rate of change would be. That's what average rate would be. It's how much on average you're increasing from here to there. Now it could also be negative. For example, if we look at the average rate of change between, say, this point and a point over here, that'd be a negative average rate of change, where this is positive since we're increasing. Once again, it works just like the slope. If it's increasing, it's positive, it's increasing. It's negative, it's decreasing. Of course, if it's zero, it's flat. That could also happen if you had a point over here at the same elevation, then your average rate of change would be zero, although that doesn't mean that you stayed at the same elevation the entire time. So once again, just tells you the difference essentially on average between these 2 points, takes nothing else into account. And if I change either point, then most likely get a different average rate of change. Just remember that works just like the slope. We also make sure we understand it, what it tells us. Let's take a look at an example. And let me actually move this up a bit. We can probably, this example right here. This example I made up, but this could be fairly realistic about stock prices. So stock prices, you probably know, can go up and down on a daily and even hourly basis, and can go change quite a bit over days, months, and weeks and years. So let's say we have some stock that on July 1st, the price is $41.03 per share. Then on December 1st, and actually, something think about it. So let me change this instead of doing it this way, because what we need is, sorry, let me do it this way. So let me say, instead of saying that, since I'm not sure exactly how many days that is, that'd be harder to find out. I'd say, let's say, so 60 days later. Okay, so basically 2 months later, 60 days later, essentially 2 months, the price of the stock, same stock, is $29.46. Find and interpret the average rate of change. So obviously it's less, so no average rate of change should be negative. But we want to find out how much and kind of get an idea of what that tells us. Okay. So let's think about this as 2 points. Okay. So let's call this day one. the price is $41.03. Then on day 60, it's going to be $29.46. I guess actually this probably should be, I guess, day 0. It doesn't matter too much what we're doing here, but let's do it that way. So day 0, as we're starting out, $41.03, day 60. Okay. And think about a point then. Think about if this is a graph, what that point would look like will be 0 and then 41.03. And in the same way here, our point would be 60 and then 49. I'm sorry, it's not 49, 29. 29.46. Okay, so then our average rate of change is going to be, just think of the slope formula. Okay, so it doesn't matter which one we call our first point and second point, just be consistent. So if I do, for example, this, if I do this y minus this y, I have to do this x minus this x. So if I do 41.03 minus 29.46, and I have to do this x minus this x, or 0 minus 60. Remember we said it's decreasing. It's decreased, so the slope should be negative. We'll make sure that's going to be true, and it will be. So here, just use your calculator. And so 41.03 minus 29.46 is 11.57 over negative 60. Okay, and also let's remember what our units are, because that's useful to know. Okay, so this, our denominator or numerator, is in dollars, and this is per day. That's going to tell us something important about what the average rate of change means. Okay, so let's just do that then. Let's divide that by 60. And we'll just round this, since we're talking about dollars and cents, round this in there as cent. And that's going to be negative 0.19. And this is going to be dollars per day. Okay. Now, what does this tell us then? What this says is that on average, the stock price decreased 19 cents, or I'll just do this dollar, so $0.19 per day over the time period. So we're not trying to claim anything about what happens outside. So over this time period. So we know the stock has decreased. At least we know the stock is less now than it was 60 days earlier. But we don't know what happened in between. It may have gone up quite a bit, might have gone down a lot more, might have come back up at some point. It could have been lots of things. This only tells us what happens in those exact moments. Okay, this tells us then, no matter what the stock did in between, then basically if you decrease from the starting point, and decrease basically, not exactly because you round off some to get to the nearest cent, but if you decrease this basically 19 cents per day for 60 days, then you go from 41.03 to approximately 29.46. So just as if you decreased at the same rate. Since we're decreasing, if you decrease at the same rate every day. So basically, on average, the price decreased that much per day. Once again, it doesn't tell us anything what actually did happen during that time. It's what the average behavior was. And once again, if you change this to a different day, a different time, then this average rate of change will most likely also be different. It's not any kind of property of the function what you're studying. It's just looking at two distinct points in time and saying what happens between those 2 points. That's what the average rate of change is. And once again, it has the same properties. It works just fine. Finding the slope has the same properties as the slope. Thank you. Have a good day.